Okay, let us solve these problems on mechanical properties of matter for elasticity and Young's modulus. Okay, number one, a certain metal rod that is 4.00 meters long and 0.50 cm squared in cross-sectional area is found to stretch zero point 0.2 centimeters under a tension of 15,000 newtons. So we are already given the area, but we have to convert this to meters squared. Okay, this is what we did in this portion. Okay, um, it's stretched by 0.20 cm. That's the delta L. You also have to convert that to meters. That's why you have this. It becomes 2 times 10 raised to negative 3 meters. Okay, so we are looking for Young's modulus. Young's modulus is stress over strain. Stress is F over A, and strain is delta L over L sub O. We plug in all the values and check if they are consistently MKS. So 15,000 is already MKS. It's in Newton. We have converted this. Okay, delta L is 2 times 10 raised to negative 3, and LO is 4.0 meters. Okay, um, we plug in the values, compute, you get 6 times 10 raised to 11 Pascal. Since the values given are in, this one is 3SF, 2, 2, and 2. So we make this 2SF, 60 times 10 raised to the 10 Pascal, or you can also have 6.0 times 10 raised to 11 Pascal, whichever you want to express your final answer, as long as it follows 2SF. Okay, number 2. In this problem, you're given a steel wire, okay, has the following properties. Length is 5.00 meters. This is the original length. The cross-sectional area is 0.040 cm squared. Again, you have to convert this to meters squared. The proportional limit is 3.60 times 10 raised to the 8 Pascal. This is another word for elastic limit. Okay, what is the proportional limit? Okay, that is the point wherein up to that point, when you remove the force, okay, the object will go back to its original length. If you go beyond the proportional limit or the elastic limit, the object will no longer go back to its original length. Okay. The breaking stress is 11.0 times 10 raised to the 8 Pascal. Okay, beyond this point, the object will snap off. Letter A. How great a weight can be hung from the wire without exceeding the proportional limit? So it should not exceed 3.6. We use this value. Okay, so the proportional limit is F over A. Okay, so how do we know that this is F over A? From the unit itself, Pascal. Pascal is Newton per meter square. Okay, so F is equal to 1440 newtons, or what, just 1400 newtons. Okay, so the area is readily given. There's no need to compute for the area. It's just a matter of conversion lang. Letter B, how much will the wire stretch under this load? So we have to know delta L. Okay, how much will it stretch? Delta L is what we're looking for. We have to use the Young's modulus. It says here the Young's modulus from page 136 or section 7.2 of your textbook has a value 20.0 times 10 raised to the 10 Pascal. Okay, so 20.0 times 10 raised to the 10 Pascal. Uh, the stress is 3.6. That's the proportional limit. Okay, kasi sabi niya under this load. Which load? The load in part A. Okay. Um, the delta L is unknown. The original length is 5.00 meters. So we transform this equation. You get delta L is equal to 9 times 10 raised to negative 3. We express our answers in uh, should be 3SF, so 9.00 times 10 raised to negative 3. So far lahat ng ginamit natin in three significant figures. So this one should be 9.00 times 10 raised to negative 3. Letter C, what is the maximum weight that can be supported? That would be based on the breaking stress. Okay, the breaking stress is F over A. So we would like to know the value of F. So the breaking stress is 11.0 times 10 raised to the 8 Pascal. Okay, We multiply this with the area. Ito yun, 4 times 10 raised to negative 6 meters squared. You get 4,400 newtons. Okay. Uh, of course, it's much bigger than 1/4 because the braking stress is much, much farther away from the proportional limit. Okay. If you're going to plot this, no. Number 3, the elastic limit of a steel elevator is 2.75 times 10 raised to the 8 Pascal. Find the maximum upward acceleration that can be given a 900 kilogram elevator. So itong 900 kilogram, we need to convert that to newtons. Okay, so 900 times 9.8, you get 8820 newtons, 8,820. Okay, so elastic limit is given. We can find uh, okay. Sabi niya, when it is supported by a cable whose cross-sectional area is 2.00 cm squared. So, convert that kasi kailangan naka-MKS, no? Pag ginagamit natin yung Young's modulus. Okay? It is not to exceed 1/4. What is 1/4? It is 1/4. So, we multiply 2.75. We multiply this by 1/4. You get 6.875 times 10 raised to the 7 Pascal. Okay? Um, ang hinahanap dito, the acceleration, maximum upward acceleration. There are two forces acting here. You have the weight of the elevator downward, which is 8,820, and the force that you supplied upward when the elastic limit is 6.875 times 10 raised to the 7 Pascal. Okay, so we skip muna itong number 4. Now let's go to the lower part. Okay. Yeah, so we need to compute first the force that is supplied when you have this amount of pressure. So the force that was supplied is 13,750 newtons. We do from second law of motion, a summation of forces along the y, the F net is equal to m times a because these are unbalanced forces. So what is the force upward? It's 13,750. What is the force downward? It's 8820 newtons. Okay, the mass is 900 kilograms. We would like to compute for the acceleration. So the maximum possible acceleration upon computing is 5.48 times meters per second squared. In 1SF, this is just 5 meters per second squared. Okay, let's go to number 4. In problem number 4, a copper wire with length 1.40 meters has a diameter 3.0 millimeters. Okay, of course, this one, we need to convert this to meters, so 3 times 10 raised to negative 3. But what we need later on would be the radius, so we divide 3 by 2, you get 1.5. What is the force constant K for this wire? Now remember last meeting, we defined the force constant K. This was introduced by Robert Hooke with his formula F is equal to Kx. Now that F is the same F that you will find here. Okay, itong F. So instead of F, we wrote Kx. Okay, well, Young's modulus is stress over strain. We get, again, yung copper's Young's modulus from the book. Anong page yun? From page 136, section 7.2. Please take note of the page. Okay. Uh, Copper's Young's modulus is 11 times 10. Ang hinahanap dito, what is the force constant K? So, we substitute F. Okay, instead of writing F, nilagay natin Kx. This was introduced by Robert Hooke. Okay, so we plug in the other values, F over A, delta L over LO. This is stress over strain. Okay, the area, we can solve that. Okay, pi r squared, ito yun, pi r squared. Now, yung x and this delta L can be cancelled out. Ayan, x and delta L because they mean the same. It's the amount of stretch. No? And then the original length is given. The original length is 1.40 meters. It says here 1.40 meters. And then this is the radius. Ito yung kinompute natin. We square it. We can compute now for the K value. Okay, the K value, according to Robert Hooke, has the unit Newton per meter. Okay, so upon computation, tumama naman, ano? So which validates our substitution of kx into this Young's modulus equation. Okay, so press your calculators. You get 5.6 times 10 raised to the fifth Newton per meter. Okay, let us go to problem number 5. In problem number 5, you have this. A nylon rope used by mountaineers elongates 1.50 meters under the weight of an 80.0 kilogram climber. Okay, so we substitute convert 80 kilograms to newtons. It's 784 newtons. And then, yung mga MKS, we convert pa. 12 millimeters becomes 0.012 meters. And the question in letter A is, what is the Young's modulus for this material? So Young's modulus is F over A, delta L over LO. The F is 784 newtons. Area is pi r squared. This is 6 because 0.012 divided by 2 is 6 times 10 raised to negative 3 squared. Ano? This one is squared, pi r squared kasi. We compute this first, we get this value. And then the stretch is 1.5 as mentioned in the problem. Ayan, elongates 1.5. And the original length is 50 meters here. So we compute for the Young's modulus of the nylon rope. It's 2.31 times 10 raised to the 8 Pascal. In letter B, you are asked what is if the Poisson's ratio for nylon is 0.20, find the change in diameter under distress. Okay, the Poisson's ratio, this is our symbol, no? It's 0.2. It means the lateral strain over the longitudinal strain. This here, in Young's modulus formula, delta L over L sub O is the longitudinal strain, and we have computed it. It's 0.03. Okay, so we substitute 0.03 here to know the lateral strain. Why do we need to know the lateral strain? Because the lateral strain is delta D over DO, the change in diameter over the original diameter. Okay, um, we the original diameter is 0.012. Okay, we substitute. Okay, so compute for the lateral strain and then substitute DO. You will get 7.2 times 10 raised to negative 5 meters. Okay, please do this. Okay, compute this at home. Number 6, a steel post is 15 centimeters in diameter and 3.00 meters long. Okay, it is placed vertically and is required to support a load of 8,000 kilograms. So itong 8,000, we are going to convert that to newtons. You get 78,400 newtons. Okay. You are asked, what is the stress in the post? In this post, stress is F divided by area. So pi is 3.14. We calculate, you get 4.4 times 10 raised to the 6 Pascal. Letter B, you are asked what is the strain in the post. Now we know that the strain is stress over Young's modulus. The Young's modulus of steel, again from the textbook, it is 20.0 times 10 raised to the 10th Pascal. Okay, so strain is stress divided by Young's modulus. Strain is a unitless quantity. So Pascal and Pascal will cancel out. You get 2.2 times 10 raised to negative 5 meters. Now, the strain is a very small quantity. Okay? That's why as expected, times 10 raised to negative 5 ang nakuha natin. Letter C, what is the change in length? Since we have already computed for strain, delta L is equal to strain times the original length. Okay, you get 2.21 times 10 raised to negative 5. We multiply this by the original length. So the stretch is only 6.6 times 10 raised to negative 5 meters. Yan lang yung stretch ng object. Okay? Number 7. A 100 kilogram mass suspended from a wire whose unstretched length is 4.00 meters is found to stretch the wire by 6.0 times 10 raised to negative 3 meters. Now, the cross-sectional area of the wire which can be assumed constant, is 0.10 cm squared. So, of course, itong 0.10 cm squared, we have to convert that to meter squared. Okay? So, Young's modulus lang hinahanap, F over A. Okay, so the F is 980. The area converted from point 0.1, you get this. Okay, calculate this first, you get this one. Okay, this is 98 million Pascal. The delta L is given. The change in length is 6 times 10 raised to negative 3. It's already in MKS. Naka-meters na siya. No need to convert. And the original length is 4.00 meters. Naka-MKS na rin. We compute for these two sa baba, 1.5 times 10 raised to negative 3. Again, unitless ang ating strain. This divided by this, you get 6.5 times 10 raised to the 10 Pascal. Okay, thank you very much. Now, please compute all of these again. Do this at home. Okay, practice. Thank you.